Hello and welcome to the second video of Intro to R&R Studio. So this is video 2. So in video 2, we're going to load data into RStudio. We're going to obtain descriptive statistics. We're going to walk through how to create new variables and recode existing variables, create a table, and run some basic graphs. Oops, we're not in video 3 yet. Let me go ahead and close down the slides for now. And then we can move over here just so I have reference of it as I'm going through this. Okay, there we go. And so a couple quick things. In the previous video, I called the pound symbol or the little hashtag and ampersand. Apologies about that. But yep, we have a pound symbol, and that's just going to be the comments. And I don't use a lot of section breaks personally. So, I mean, they're okay, but you can go ahead and you can collapse them. So I forgot to mention the benefit of that. Um, with this one, if we're doing something like a markdown file, which we're not running, here's our version. Yeah, we're not going to see that change here. Yeah, if it's a markdown version, that would change the header though. So I jump around between R Markdown and R Script. This one's just using an R Script. So I just wanted to mention that, kind of circle back to some stuff in video 1. Okay, so what we're going to do now, since we already loaded in our libraries, now we're going to go ahead and set the working directory. So this is probably one of the most confusing things within R. And we're going to walk through this a couple of times. So the first thing we need to do, think of it as working directories. We're telling R what folder to work out of. So if you downloaded the data set we'll be working with and put it with the R file, what we need to do is we need to go to session, set working directory, and the easiest thing to do here is choose file direct or choose directory. I'm going to go ahead and find where my R script is. So it's in there. Let me pull up another Explorer tab so you can kind of see. So we're not going to see any files in there per se, but we're just telling R where to work out of. So we can see right there's the CSV file we're going to be using, and it is in the same folder. So I'm going to go ahead and I'm going to click on Open. That way, this is the exact command here. Now, out of practice, I don't recommend putting this within your R script because if you were to send this to someone else, or if I've had this specific file path in the script and you went to use it, well, that file path doesn't exist for you. You don't have a user called eSchuler, or you shouldn't. So this is specific towards me and my computer. So it's gonna be different for you. So that's why I recommend not putting this in the script and just doing the session, setting work directory each and every time. That way it's more control within this. It makes it just easier. So again, to set the working directory, which is a critical step, go to session, set working directory, choose directory, and you're going to go ahead and click to where you want it saved. If you have your R script and your data in the same one, at the same location, click on set source location. If it's in two different locations, then you want to make sure you specify that. So again, set the working directory, session, set working directory, and then go ahead and locate it. Sorry, I feel like a broken record right now, but this is the biggest issue I've seen for new users. So I really want to mention this several times. So when we're importing data, the easiest data to work with is going to be a CSV file. The nice thing is it's easily to transport. You have to format it, but it's just the easiest thing to read in. And we just want to mention that the header is true. That way it knows the first row is actually going to be our variables. So if we pull that in, we're reading the CSV file and we're assigning that to an object called CS. If you have other things like an SPSS file or SAS, we can use the Rio package, which we installed here. And I can just say library Rio, and then I can go ahead and uncomment this out and import it that way. For new users, what you can also do is you can go ahead and click on, in the environment panel, click on this little grid. We can say, okay, if it's an SPSS file, I can go ahead and locate it. And I'm going to go ahead and Let's see. Do I have it? You know what? Let me go and do this as a data file. That'll be just easier. I like using Rio personally, but this is another option where you can go ahead, browse the file location. I can go ahead and say if it was let's say it's a data file, and click there. It's going to go ahead and preview it, and I can go ahead and import it, and then there's the code. So it's a good way to quickly check it. And if you're first using R, a quickly way to kind of double check it too. And just once you get used to doing this, you'll learn the code. So do what works best for you. There's many ways of doing this. Just do what works for you. So go ahead and just move this zoom control out of the way. There we go. So the nice thing, R can read almost any type of data sets in there, Stata, SAS, Excel, an R data file, which is a formatted version. So whatever you want to do, it's in there. So first we have our data frame here. So each row is a country, and each column is a variable. So this is what is sometimes called wide format. So each country is only in there once, and each one country is a row. If it's like multi-level data where you have multiple instances for the same country, multiple years, that's gonna be a long format. If you say like Afghanistan 5 times, with each one being a different year. We're working cross-sectional data, so it's gonna be wide format for this. So let's say we want to take a look at the names, just making sure it read in the right way. So I always do this with every data set, just to ensure, hey, it read in right. So check the call names, just the column names. I can also expand this. If it's a really large data set, it's going to cut off after a while. We can also check the structure to see, okay, did it read it in as a character? So country is a character, OECD member, it's a dummy coded 0, no, 1, yes. It's an integer. We have a numeric, which has a decimal point. And then we have NA. NA is missing. So if we double click on this, wherever we see an NA, that just means it's missing data. We can also use glimpse, which gives us a little bit more information about it. And we can kind of see more observations within this too. If we wanted to see the first 6 observations in the data set, we can use head, which is a function, and then reference our data frame. So now we can go ahead and run that. And there's our first 6 countries. If we want to take the last 6 cases in the data set, we can go ahead and run a tail, and that will give us the last 6. So for descriptive statistics, what we're going to do is we're going to use first our default summary command, and then I'm going to show you some ones that I like personally. So if we were to do summary, the function summary on the entire data set, we're going to get for every variable, I mean, for a country, it's going to say character, and it's not going to give you anything else. But for OECD member, it's going to give you the mean, first quartile, third quartile, median, minimum, maximum. So if we look at corruption, our minimum and our maximum, number of NAs or missing data, our mean, our quartiles, and our median. It's okay. It's a lot of information, but if I go ahead and do summary, the data set $, the specific variable, I can get just that summary on a single line here. So minimum, maximum, first quartile, third quartile, median, and the mean. Now, this is a dummy-coded variable, so I wouldn't recommend using OECD member. So instead, what we could do is we could use, oh, sorry, this was duplicated. I'm going to delete this in the script that I post. Let me fix that really quick. What we can do is we can also use the describe function from the psych package. So when we do that, it gives you a little bit more different information. So let's see, for our corruption, it has the sample number of observations, the mean, standard deviation, median, trimmed mean, MAD, min, max, range, skewness, kurtosis, and standard error of the mean. So it gives you much, much more information. We can go ahead and do this for a specific variable rather than doing for the whole data set. So that's the same information. We're just pinpointing it a little bit more. So before I had mentioned that corruption is reverse coded. So that means right now, higher scores reflect lower perceived corruption. So I'm trained as an experimental psychologist. I don't like that coding mechanism. Instead, what I prefer is I prefer higher scores to mean higher levels of that construct. That makes more sense to me. So we're going to go ahead and we're going to reverse score this. So we're going to flip it. So we're going to do 10 minus CS corrupt because it goes from 0 to 10. So it's 11. So we're doing 11. So if it's, oh, sorry, it's 1 to 10. So if we take that, we're going to flip it. So that way, if they have a 9, it's going to become a 1 and so forth. So essentially going to go ahead and create a new variable based on the old one. We're calling that corrupt2, so we're changing this into a new variable and not overriding it. That way we can always go back to the previous one just to check. So I'm going to go ahead and open up our CS data frame. So if we have a 2.5 for corrupt, it is now a 7.5. We add that together, it's 10, which is the max. We have 2.4, 7.6, that works. So I like to always give this a quick double check. So what we can also then do is we can also recode a variable into a categorical one. So let's say we want to take our corruption variable and put that into high, medium, and low. Well, we can do that, but first let me give you a word of warning. So let's say we have our corruption on our x-axis, and here we're just going to go ahead and put it's going to be frequency. And let's say we have this here, all of our values from 0 for now to 10. And let's say we go ahead and, oh, here's the draw tool, to 10. If we bin it, so essentially we're going to have a low bin, a medium bin, and a high bin. So if we do that, we're essentially saying everything from the lowest value, the minimum, to less than 3.3, because 3.3 is going to be where that line is, treat all those as the same. So essentially, a value here that's right on the edge, or a value here right on the low, we're treating that as, essentially, they're saying they're equal. We do the same thing for median. Essentially, all those are equal, even though from here to here, they are more closer here than the group centroid. So for interpretation purposes, it does make it potentially easier to interpret. However, you do run the risk of losing variability. So just a word of caution. So it really depends on the discipline, but do use caution when you discretize or categorize a continuous variable because you're going to lose variance. So now what we're going to do is we're creating a new variable called corrupt catig, and we're saying in the square bracket, when the corruption 2 is less than 3.3, assign a 1 to corruption catig. We're going to go ahead and use a logical operator saying, okay, for assign a 2 when, to corruption 2 when, sorry, corruption catig, assign that to a 2, when corrupt 2 is less than or equal to, or is greater than or equal to 3.3, and it's less than 6.6. So we're creating these as mutually exclusive. That way, a single value that's right on that edge, it can't be in both. So making sure they're mutually exclusive. So we're going to do that. And we're going to say when it's greater or equal to 6.61, assign that as a 3. And I'm going to go into the data set here and see, okay, this was greater than 6.61, so that's a 3. We have here, this was a 1.2 on corruption 2, it got put into a 1. So we're binning the data set. I can run a table here, and now I can go ahead and check. So how many cases we have in each one. We can then add some different information for labels. So I'm going to say this is an ordered function. So I'm going to say this is an ordered, because we think of it as high, medium, low, or sorry, low, medium, high, or bronze, silver, gold for the Olympics. We're saying taking our variable of corruption catig, it's an ordered factor. The levels are 1, 2, 3. We're assigning a 1 as a low. We're assigning the level 2 as a medium, and we're assigning 3 as a high. So when we run that, now we're assigning those levels to it. If we scroll down, here now we can see, okay, this is an ordered factor now. And if we do a table here, the table function on corruption catig, we have 23 observations for low, 44 for medium, and 83 for high. We can also change that binary variable of OECD member, that's 0 and 1, so no is a 0, 1 is a yes. So saying use the factor function on the variable OECD member, whereas we're overriding the existing variable. The levels are 0 and 1. 0 is a no, 1 is a yes. So I'm going to go ahead and run that. We can use our table. And now we have 187 are not a member and 30 are a member. What I like to use janitor for this because then I can actually get a frequency table. So I can run table CS Dawson OCD. Now, if you have the library for janitor loaded, you don't have to do this. But if you only wanted to use a specific one function from a package, you could say the library name, two colons, then the function. That way you don't have to activate it. You can just use that single one. This is just as practice. I'm going to go ahead and run that. And now we have what the levels are, the frequency, and the percentage for that. So that's a really nice thing. We can also copy and paste that out, and we're good to go. So next thing I'm going to do is we're going to go ahead and do crosstabs. So we're going to take a look at two categorical variables at the same time. And we can save this as a table to return later. So we're going to say for the table, we want OCD member or OECD and corruption categ. We're taking that and we're assigning it to something called corruption table. So now we have our table here under values. And if I print it, there's our table. So we have OECD member, that's going to be our rows. And then we have our corruption categ, which is going to be our columns. We can see our proportions by saying table, a proportion table function, the table, comma 1. That's going to give us our row proportions. We can also see our column proportion by changing that 1 to a 2, so using that comma. So now we can see what the proportions are for the columns. Let's say we wanted to add sums. We can add margins to the table. And that way we have our by row and our by column sums. We can also combine the two commands. And we can also run a chi-square test. We can do summary based on that table here. And now we can say, okay, for this, we can do a test of independence of all factors. And this is statistically significant. What I like to do is I like to do options, parentheses, psi pen equals 999, because I do not like scientific notation. If I do that, now it's going to go ahead and print out the p-value non-scientific notation. I prefer that. We can also do a histogram. So we can do a really basic one by just using the histogram function, the object, and then the variable name. So if you run that, here is our histogram. It's okay, but we can make it a little bit prettier by saying we can change the name of this to GDP per capita, and we're going to add a subnote here saying where the source of it is sub, and that is from World Bank 2010 and XLab. So that makes it a little bit easier. We can also change this to GDPP. GDPP. C. There we go. Let me go ahead and leave that blank. So if you want to go ahead and fix that on your own, you can do that. So that's how we can go ahead and do this. Let's say that we wanted to aggregate data. So if we wanted to calculate the average corruption for each of our groups, so the high, medium, and low groups for corruption category, and we wanted to get what the average for GDP-PC was, we can go ahead and use the aggregate command. So we're going to do this aggregate command. We're going to say CS, and we specifically want GDP-PC. We're going to use a list of corruption category. We're going to have it calculate the mean, and if it's missing, we're using just remove. We're going to aggregate this up. So now I'm going to go ahead and I'll just put it in here, GDP. Corrupt table. Okay, there we go. So now we have our grouping variable, and then we also have our GDPPC, which is the mean for each of our groups. Let's see, so what did I corrupt? Oh, I inverted G and P, or the D and the B. So it's going to give you an error message if you mess that one up. So now we've done that, we can then go ahead and say, okay, I want from our GDPP table, take our X, which is going to be our GDPPC, give our main in our X lab here. So we're adding our main, so that's going to be our figure name. Our Y label is going to be the label for our y-axis, and our X label is going to be corruption category. So when we do that, now we have our corruption categories here. So, I mean, it's okay. Um, but yeah, it's a basic box plot that we can go ahead and do. So what we can also do is we can do a scatter plot. So to do that, what we can do is we're going to plot the CS corruption category 2 and our GDBPC. Actually, we're going to pause here and we'll pick this up in video 3.